Hello. Yes, we welcome you back to PSSB with me, Richard here. Okay, tonight we are looking at this question. It says that in an experiment to determine the concentration of hydrochloric acid, 30 cubic centimeter of sodium carbonate solution of concentration 0.1 moles per cubic decimeter neutralizes 20 cubic centimeter of hydrochloric acid solution. And the question says, how many moles of sodium carbonate are there in 1 cubic decimeter of the base? Okay, if you analyze this question, our base is sodium carbonate, and we are given the concentration. But when you analyze the concentration, this is what you see. The concentration is 0.1 moles per cubic decimeter. Actually, if you expand this one, this means this. It means that 0.1 moles are contained in 1 cubic decimeter. Yeah. So the question says that how many moles are there in 1 cubic decimeter? So what is the answer? 0.1. Yeah. Then comes this question. It says, calculate the mass of sodium carbonate in 1 cubic decimeter of the base. Okay. So how do you go about this one? This is what you have to know. We are looking for mass. But what do you know? We know concentration, which is 0.1 moles per cubic decimeter. What else do we know? We know the volume. We have been given the volume. The volume is 1 cubic decimeter. Okay. So from here, what do we do? You pick the equation which has concentration and mass, and that equation is going to be C is equal to mass over molar mass times volume. So when you look at the equation, what do you notice? That you are missing one of the necessity to calculate this, which is the molar mass. So what do? We come here and do the calculation of molar mass of sodium carbonate. Okay. So what do? We have sodium, which is 23 times 2. You have carbon, which is 12. Then plus oxygen, which is 16, but times 3. Yeah. So our molar mass is 106. So it's like now we have all the data to do the calculation of the mass. So what do? You substitute. So our concentration is 0.1. Our mass is needed. Our molar mass, we know it, 106. And our volume is 1. So from here, after cross multiplying, what are we going to get? We are going to say mass is going to be equal to 0.1 times 106 times 1, giving you, giving you 10.6 grams. Yeah. Then we come to this question saying, calculate the concentration of hydrochloric acid. Okay. How do we go about this? Now I need this. So when a question comes like this one, where do we start from? You analyze the question, and from analysis you realize that our standard is sodium carbonate. So sodium carbonate being our standard, what do? We start with it. And what are you going to say? We are going to say calculating the number of moles of our standard, which is what? Sodium carbonate, which reacted. We must not forget that we move from known to unknown. So if we come to this level, what do? Okay, to perform this calculation, we need to find out what we know. We know the concentration of our standard, and it is 0.1 moles per cubic decimeter. Okay, we know the volume of sodium carbonate which reacted, and it is what? It's 30 cubic centimeter. So what do? You convert it to cubic decimeter by dividing with our 1000, giving you 0.03 cubic decimeter. Okay. And we are looking for N. Remember, you're calculating number of moles of sodium carbonate which reacted. So with this information, what do? You proceed and get our equation. The equation is C equals to N over V. We know our C, which is 0.1. Our N is wanted, and the volume is known, which is 0.03. What do we do here? You get your N after cross multiplying, and it's going to be, N is going to be 0.1 times 0.03, giving you that. Yes, giving us this, which is 0.003 moles. So these are the moles of what? Of our standard which reacted. Okay, so these are the moles of sodium carbonate. What is the next step? Next step is calculating the moles of our unknown, which is hydrochloric acid, which reacted. So what are you going to say here? You're going to say calculating the number of moles of what? Of hydrochloric acid which reacted. Okay. Yes. How do you go about this? Now I need to tell you that the link between the number of moles of the standard which reacted and the number of moles of the unknown which reacted is through mole ratio. But the question is, how do you get mole ratio? By writing a well-balanced equation. So when you look at the scenario, what do we have? We have our sodium carbonate. Okay. We are adding hydrochloric acid. From here, what do we get? You get sodium chloride as our salt. Okay. We are getting water. Okay, and we are having carbon dioxide. So our step which comes next is balancing. We are having one sodium here and 2 here, so we put a 2 here to balance sodium. But that one makes chlorine to be 2, so you put here to balance chlorine. And the equation is now balanced. So after balancing the equation, what do we get from equation? We get mole ratio. So from here, it is very clear that the number here, because we look at the ratio here, is 1. And the number here is 2. Okay. So if that is true, then you bring your number of moles of sodium carbonate, because it's known it is 0.003. So you put it under sodium carbonate. So it's going to be 0.003. And our unknown is this one. So it becomes X. So how do we get X? We get it by cross multiplying. So this is what we get after cross multiplying. 1 times X is X. Okay. Then we have 2 times 0.003, giving you what? 0.006 what? Moles. So what we have here are the number of moles of hydrochloric acid which reacted. So next step is to have all the information about hydrochloric acid. So this is what we know. We know the number of moles which reacted, and it is 0.006 moles. Okay. What else do we know about hydrochloric acid? We know the volume which reacted, and it is 20 cubic centimeter. Converting this one to cubic decimeter, you divide by 1,000 to give you 0.02 cubic decimeter. So what is pending here? It is the concentration which we are looking for. So with this information, what do? We go for the kill. We have the equation which says C is equal to N over V. Okay. And we know N, which is 0.006. And we know V, which is 0.02. What you get out of here is going to be the concentration of hydrochloric acid. Yeah, so this is it. The concentration of hydrochloric acid is 0.3 moles per cubic decimeter. Yeah, so comes this question. It says, state the best indicator for this titration. Choose from methyl orange, phenolphthalein indicator, and bromothymol blue. Explain your answer. Okay, to choose the indicator, what do? You look at the reactants. We have our base, which is sodium carbonate, and we have our acid, which is hydrochloric acid. Okay. Then what do you do next? You look at the nature of each. Sodium carbonate is the base. But what is it? Is it a strong base or weak base? It is a weak base. Okay. Hydrochloric acid is an acid. Is it a strong acid or weak acid? It is a strong acid. Now, I need to remind you that it is the strong which takes the pH. This implies that the pH of our resultant solution is going to be acidic. Why? Because it's the acid which is stronger. So the medium is acidic, but the question is, which is the best indicator for the acidic medium here? The indicator is methyl orange. Okay? And the question is, why? Why has our explanation? What's the reason? Okay, the reason is that the reaction is between a strong acid and a weak base. That means that the resultant solution is going to be acidic. Yeah, that is it. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. Yes, we urge you to subscribe, to comment, to like, to share. And we also have to remind you that this channel, Physical Sciences Silver Bullet, is a science channel handling physical sciences grade 12, 11, and 10, and natural sciences grade 8 and 9. We advise you that if you're using the channel, try using our playlist. Just go to the playlist and look for the material which belongs to your level. For grade 8 and 9, just look for natural sciences grade 8 or natural sciences grade 9. For grade 11 and 10, look for physical sciences grade 10 and physical sciences grade 11. As for grade 12, every chapter is presented independently. So look for the chapter of your choice and you'll have all the material which you need from that chapter. We say thank you, stay blessed, see you next time. Bye-bye.